Go ahead, take a look at that first section. We're going to review how to find the perimeter of area of different shapes in the coordinate plane. Few important formulas you need to know. Area of a triangle, which is 1/2 base times height, and area of a parallelogram, which is just base times height. You're going to be given these formulas. You don't have to worry about memorizing them. You just have to know when to use them. Okay? So, we want to determine the area of a quadrilateral with the following vertices. Well, I'm going to help you out here. This quadrilateral is a parallelogram. Okay?
Oh, that's what I got.
It is a parallelogram. You can jump into that formula. You have to show that it's a parallelogram first. We don't have to worry about that right now. We're just going to say it. So, in order to find the area, what do we need to do with all these points? Yeah, plot them. We'll plot -5, 2, 7, 6, 9, 0, and -3, -4. And we know it's a parallelogram, so we can go ahead and use this formula. Well, we have to multiply to find the area of the base times the height. Here's the thing, we don't know the distance of the base or the height. They're not nice and flat, so we just can't count them. They're slanted. So what do we use to find the distance in the coordinate plane? Jane? Yeah, very good. We're going to use the Pythagorean theorem. What is the Pythagorean theorem again? A squared plus b squared equals c squared. So we can use this to find the base. There's two bases, so it really doesn't matter which one you use. I'm going to go ahead and use this one. We're going to go up and over. We're going to make a right triangle. The side, the distance you're trying to find is always your c. So then you go ahead and count to find those. Okay, so go ahead and count up. How far do we go up? 4. The length of this side is 4. What's the length of this side? 4. Okay. Those are the lengths of the sides of this triangle. You can just count them because they're nice and flat. Plug those in the Pythagorean theorem. We're going to do 4 squared plus 12 squared equals c squared. What is 4 squared? Good. What's 12 squared? What's 16 plus 144? What is it? 160. And then again, what do we have to do to both sides? So c is equal to square root of 160 for right now. We're just going to leave it as a square root of 160. Don't worry about simplifying until the very end. Okay. So that is our base. Okay? Found our base. Now you do the same process to find your height. Again, we have two heights. It doesn't really matter which one you use. This one is your right triangle. Again, the side you're trying to find is always your C. What's the distance of this bottom part, the bottom side? What is it? Oh, it's okay. Great. What's the distance of this up and down side? Yep, 5. One more, 6. Okay, plug it in the Pythagorean theorem. You're going to get 6 squared plus 3 squared equals c squared. 6 squared is what? 6. 3 squared is 9. 36 plus 9 is 45?
I did it.
Think. I did. For which one? For D. Let's just leave it. It's 2 3. Well, pretend it's -3.
Oh, what happened?
So when we add these 36 plus 9, we get 45. Square root both sides, what do we get? C is equal to, again, we'll wait till the very end. No. Okay. Sorry, it's off by a couple numbers. What in the wrong spot? Alright. So this, when we make this triangle, it's 1, 2. That's 5, probably. That's 2 squared, which is 4. Sorry about that. I know it's a little earlier. Shout it out. And then this guy is 1, 2, 3, 4, 5, 6. That's so sick. Okay. So this is actually just 40. So it's off by a little bit. That's fine. Alright, that's your height. So once you use the Pythagorean theorem to find the distance of your base and your height, you just use the formula. You just multiply them together. All you have to do radical 160 times radical 40. Well, remember when you multiply radicals, multiply the numbers underneath. What's 160 times 40? They're a really big number. Not so. Yeah, what do you get when you do 160 times 40? 6,400. Check and see if this is a perfect square. If not, we need to simplify it. What's the square root of 6,400? We get a whole number? Yeah, what do we get? 8. So simplify needed.
Why can't you just use square root of 160 times square root?
That works, but we're just working on having more numbers. Because your answer didn't end up being a perfect square, we might need to simplify it, and by doing that, you could sometimes you get a decimal.
This one happens to work out.
Yeah.
Because if you do square 160, it's going to be a decimal.
Yeah.
Square 40 is a decimal. Just happen to work out that it'll be a perfect square again.
If you do like the square root of 7 times the square root of 19, you're not going to,
Well, one frustrating thing dealing with like really long decimals like this when like working your calculator, you can't really put those kind of decimals in because it doesn't record the entire decimal.
Yeah.
Go on for a while.
Yep.
Even if you put like answer, that's not the whole decimal, so your answer.
That's why rounding is such a key thing.
Yep.
Work on the skill.
But not even rounding.
Let's go on to number 3 here. Determine the area of a triangle. All right, well, it's not area of a parallelogram. That's pretty straightforward. But area of a triangle is a different beast. The formula is actually very similar with one difference. And it's on your paper. You can cheat. You sound like real genius here. What is the area of a triangle? Yeah, you guys felt like genius there, huh? Area equals 1/2 base times height. Once you guys have that memorized there. Well, that's great. But just like the other problem, we don't have any lines that are on either horizontal or vertical. We don't have any things that are straight lines. All these sections are diagonals. So we can't just say, all right, the base is whatever, the height is whatever divided by 2. It does not work. So there's a couple of different ways to do this, but the nicest way to do it is this. We're going to make a parallelogram out of this figure. We're going to enclose this triangle inside a parallelogram. So I'm going to do that right now. I'm going to color coordinate them so you see what they are. But I'm going to enclose this into a figure here, into a parallelogram. Okay. You see how that's inside of a parallelogram right now? This is how we're going to solve these type of problems. When we don't have things that are on straight lines, finding out area, we're going to have to do this, especially with triangles. Well, do you notice that with the green, the blue, and the red together, they make that parallelogram? Let's find the area of that parallelogram. So I'm going to find the area of the whole thing first. So what do? I have to figure out how long the pieces are. So just like before, I'm going to do base times height. Let's say this is my base. How wide is it from the green to the blue section? 1, 2, 3, 4, 5, 7. That's 7 units. How tall is this figure? What's the height of this figure? This is how we're looking at it. 1, 2, 3, 4. Okay, 4. And to find the area of a parallelogram, just like before, it is base times height. So I had a base of 7, you guys said. I have a height of 4. And this is going to tell me the area of the whole thing. So the area of the whole thing is 28. I agree. And we'll deal with units in a little bit here. So the whole thing is 28. But do I care about this parallelogram? Is this my final answer? No, that is not my final answer. My final answer is I want this. What do you want this bad boy right there? I want that. Do I want the green one, the blue one, and the red one? I don't want it. I know what the whole thing is. I don't want those. Let's get rid of them. So let's find what each of these triangles, the area that each of these triangles occupy, and then subtract them off. So let's do that. Let's do the green one first. We're going to find the area of that green triangle, this upper left one. Nope. Find the area of the triangle, the area of the formula is 1/2 base times height. We just got to figure out what this base and this height is. The reason why it's nice is because now they're on straight lines. I can easily count those. No need for Pythagorean theorem. So I know this side is already 4. This side right here is 1, 2, oh, another 4. So let's find the area of this green triangle. So I'm going to say 1/2 base. What's one of my bases in the green one? 4. What's the height? Half. Same thing. 1/2 base times height. 4 times 4. 4 times 4 is? Half of 16 is? 8. So I know the area that this green one occupies is 8 square units. All right, cool. Well, I'm going to get rid of 8 at my very last step, but let's keep going and figure out what the other pieces are. Let's look at the blue triangle. Let's figure out these sides of it. 1, 2, 3. That'll make sense. 4 plus 3 is 7. Other side right here. 1, 2, 3. Another 3. So now I have my base and my height of that blue one. So area, again, equals 1/2. And the blue one, what's one of my bases? 3. What's my height? 3. Again, those are interchangeable. I realize they're the same numbers. Other ones, they won't be the same numbers, so don't worry about it. 3 times 3 is? Half of 9 is? 4 for my decimals are okay right here. So I know this guy is 4.5. One last triangle, and it's this red guy. It's a little sliver down here. So let's count. Well, the nice thing is it's a parallelogram. So this side's 7. This whole side has to also be 7. This side's 4. This side has to be 4. So this means that is 1. We'll just count. Doesn't matter. So now I have my base. I have my height. Let's put in the formula. So area equals 1/2. What's my base in that red triangle? What is it? I know you're tired. You guys are staying up till midnight, catching up on Stranger Things, and This Is Us. This Is Us. You watch that show? Great show. I'd recommend it. Modern Family. Survivor. Don't watch any of those shows. Those shows I watch.
I don't even really watch TV.
Yeah, I need to watch. Wednesday's usually my TV day, but with Survivor gone, I don't watch Survivor anymore. So, I don't do it. What's the base? 7. What's the height? There we go. Get our calculators quick. Tabulate this. 1 times 7. Tricked you. Don't need a calculator for that. Half of 7 is 3.5. Now, that's 3.5. Well, how's that help me? Again, I don't care about the green, red, or blue. I want that yellow section in the middle. So since I know what the whole thing is, I'm going to subtract the green subtract the blue, subtract the red, and I will have my final answer. So the area of that triangle is going to equal 28 minus 8 minus 4.5 minus 3.5. So the area of this triangle is something units squared. So I do 28 minus 8 minus 3.5 minus 4.5. I get this number. This number is, Jacob, 16, 12. 12 units squared. Why is there a dot above the n? I don't know. I just put it there. Question on that. Again, make sure you know how to do this skill. Subtract off the difference. Ready, set, another triangle.
Hey, if you flip it over the back, we want to determine the perimeter of the triangle using the following vertices. So how do you find the perimeter of any shape? What do we do with all the sides? We add up all the sides. So in order to figure out what the sides are, what do we always need to do first with these points? What do we need to do? With the points? Look at them. Not anything else. What do you need to do? Plot them. We have negative 4, negative 2, 4, 8, and 7, 2. I have this triangle. In order to find the perimeter, we have to add the distances of all three sides. Well, we don't know the distances of all three sides. They're all slanted. We can't easily count them. So, what do we use to find the distances? The coordinate plane. We use the, what is it? Pythagorean theorem. So again, you make your right triangle. You're trying to find always your C. Right, well, what's the distance of this side? Count. What do we get? What, Cindy, what do you get? 10. Good. What's the distance of this side when we count? What do you get? So again, log that in the Pythagorean theorem. It doesn't matter which side you start with. I'm going to start with AB. And we're using the Pythagorean theorem. So we do 10 squared plus 8 squared equals C squared. Again, you can kind of shortcut it. Just see what 10 squared plus 8 squared is in your calculator. I'm going to save you some steps. What is 10 squared plus 8 squared? 164. Okay. Get rid of the exponent, square root both sides, and we're going to round on this one, so just keep it as square root of 164. Don't worry about simplifying. Unless it specifies and it says leave answer in simplest radical form, don't worry about simplifying. Okay? You repeat the same process with the other two sides. Alright, so we're going to find this one, make your right triangle. Side you're trying to find, always your C. So what's the measure of the side, this top part? When we count. Okay. What's the measure of this up and down? 6. Okay. Plug in Pythagorean theorem. 3 squared plus 6 squared equals C squared. What is 3 squared plus 6 squared? What do we get? Okay. Very good. Again, square root both sides to get rid of the exponent. Don't worry about simplifying. If you do, not the end of the world. It's a little more work. And then repeat the same exact process with the last side. Let's go with down and over. What is the measure of this side? Let's measure this bottom part. Plug in Pythagorean theorem. There's just a bunch of Pythagorean theorems, and that's all these problems are. Just doing it a bunch of times, and adding up your results and multiplying the results. What's 11 squared plus 4 squared? And then we'll do 11 squared plus 4 squared.
277.
That was it. I didn't think so. Did you actually multiply?
I don't know.
I think you did multiply. I think you multiplied them.
I think I did it all like in the X sort of thing.
Okay, so then square root to get rid of that square, so c is equal to the square root of 137. We have all three sides. Well, again, to find the perimeter, you just add up all those three sides together. 164, 45, plus 137. What do we get when we add all those up? What do you get? Did you do the square root?
Square roots. The square root of 164. Yep. So what is it?
31.2. We round about 31.2 units is the perimeter. About. Okay. Questions over that? If you're asked to find the perimeter, you just, unless they're nice, straight, flat sides, you just use the Pythagorean theorem to find the distance of all the sides, and then you just add those results up.
Hey, notice how 3 and 4 are very similar, but you're solving two different things. I still made that parallelogram around the outside, but now I'm just finding the distance of each side. So you kind of do the same thing, just looking for different pieces. All right, number 4. By number 4, I mean number 5. Look at this guy. Determine the perimeter of the parallelogram with the following vertices, E, F, G, H. First thing first, what I need to do? Plot points. Great thing. Do the same thing myself. And a label as well. So 1, 7. 1, 7, right about there. Call that an E. The other one is F, 8, 7. Other guy, G, O, -3. G, and H is -3, -3. H. Let's connect that up. What is nice about this one? Okay, find perimeter. How do you find perimeter again? How do I find the perimeter? Add up all the sides. Eminem wrote a song about it around the outside. I was actually listening to that today because I was playing the song for one of my classes. Guess who's back? Back again. Maybe you guys are back in school. And that song, that lyric's on there. Around the outside, around the outside. He dresses up. It's Eminem. Dresses up like Batman or Robin. Excuse me. You guys haven't seen that music video? Yeah, you see it. You know what I'm talking about. Great music video. Go watch it. All right. Anyways, we have to add up the outside. That's how we find it. We add up the distances of the sides. What's nice about this one, though? Ben? You're right. Why is that?
Because
You're on the right track. I know you're thinking.
it's a rectangle.
Ah, not a rectangle. It's a parallelogram. That's right. So he's right. I only do need to do two problems. Because if I figure out what one side is, doesn't the other side automatically have to be that same distance? Yes, it does. And I can make it even easier. Because what is nice about this that we haven't seen yet in any of the other problems? Laura does this. Yeah, the line's straight. Can I just easily count that? Yes, I can. So I actually need one set of things based on what those two said. So let's figure out what EF. EF's real easy to figure out. What is the distance of EF? 7. 1, 2, 3, 4, 5, 6, 7. Awesome. So what's HG going to be? You could count, but what's it going to be? You know that's going to be 7 too. Because it's a parallelogram, we know opposite sides are congruent. We also know they're parallel. Save some time there. So I know HG and EF are both 7. Awesome. You know they're the same. All right, well it comes down to what do you want to find? You want to find EH or FG? Which one do you want to do? He or field goal? What do you want to do? He? All right. Let's figure out that guy. So we're going to do HE. And just like before, find distance, we're going to do that Pythagorean theorem. Starting to make my little shape, and let's figure out. We're again going to solve for this distance right here. So how high up do we go? What am I rising on this one here? Going up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like a 10. Make sure you guys are practicing along in your seats so you understand what's going on. And then we're going to go over 4. Plug that into our formula, and again, the 4 and 10 doesn't matter which one goes first. I'm just going as I see it. 10 squared plus 4 squared equals c squared. See what I did there? 4 squared. It's a game.
Oh, 4 squared.
Mm.
I used to play that.
I was pretty dominant at it. I almost went professional, but I had a toe injury held me back.
Ah.
So let's go through here and figure out what's going on. Square it up. 10 squared is hundo plus 4 squared 16 equals c squared. We know what's going to happen here. We got c squared equals 116. Get it by itself. I need to square root, the root's on fire. C equals the square root of 116. We're not going to we're rounding, so we'll save that for the final answer. But I know that this is going to be the square root of 116. Kind of what Ben said. Makes it real easy because I only need to do 2 of these. What's FG going to be? The square root of 116 as well. They're exactly the same because it's a parallelogram. And then going back to find the perimeter, we go on the outside. So we add them all up. So the perimeter equals all the sides added up. Then we're ultimately going to round our answer in our final step. So I'm going to add this 2 together. So I'm going to say 7 plus 7 plus square root of 116 plus the square root of 116. And this gives me a perimeter of this. 1 decimal place is fine rounding. If you're sitting in your seats, make sure you're trying this. We cannot help you the day of the test or anywhere else. And when you do so, you get this number. Cat, thank you. Oh no. Thought you had it. Should have turned sideways. I thought it was official. Is it 16.79? Close.
5.2.
What is it?
25.3.
No, yes. Oh my goodness, what's happening here? 10.8? No? 30, what? 35.5 is what it should be, yes. 35.5. Thank you for everyone who tried that. 35.5 units. That's it. And that's this again. This brings up a good point. Why we try this? Notice we have 4 different answers there. That's fine. That means 4 different people would write that answer on their test. So make sure you're on the same page. If you did not get 35.5, raise your hand. We'll come around and help you with that.
Well, one really hard